Hi everyone, we are Group 6 and today we are going to present our final SQL Database project for our AOS luxury restaurant. So we will start with our business scenario. Uh, our project focuses on designing and implementing a full database system that supports restaurant operation from reservation to order and billing. And our business is a local luxury restaurant branch which have multiple branches. And our key business operation is customer management, reservation scheduling, table seating assignment, order and billing workflow, and also employee management. And we also set some business rule. For example, each branch manage its own staff, table, and share the same menu item. A reservation linked to customer, branch, table, and order. Each order can contain multiple order line, and one order line can only refer to one menu item. One bill is generated per reservation, and customers can have multi-contact method. So you will see the final ERD is after we refined and normalization. We keep the main entity like reservation, customer, order, bill, and payment. And next slide, we can see more detailedly our key design decision. We scoped down our system to focus on customer and reservation, order, and billing workflow to better fit our assignment requirement. And we create bridge table to solve many-to-many relationships such as order line, bill item line table, and reservation table. We also use compose primary key for all weak entity. And finally, we normalize our database following the 1NF to 3NF process. And the key point is we create some bridge table to solve multi-value problem and composite attribute. And we also solve the transitive dependency problem, which is we create an address table for postcode, which will impact city, province, and country. And here we will see how we create our database. We create it based on our final 3NF schema. So we create the main entities such as branch, reservation, customer, and any following like big table. And we also use primary for our strong entity and foreign key to connect our each tables. And next one is we use the plural integrity rules, for example, on update and on delete rule. On update cascade for ID consistency and delete cascade for weak entity. And delete set not only when we want to keep our history data. And for our data quality, we use not null for almost our attributes, and we use unique to attributes such as menu item, name, and table number of per branch. And we use default for Boolean flags such as is active. And also we use check constructs for employee position, status, payment method, and to keep the consistency.
Hi, for our DML insertion, we follow all table constraints ensure data accuracy. For example, the address table requires a not null field, so every address record must be complete. In restaurant branch, the postal code must match an value in the address table because it is a foreign key. It is also why we insert address first, then restaurant branch. This ensures reference integrity right from the start of the data loading process. For next slide, under our ERD, we could see the branch may have more than one phone number, like a landline and fax. To support this one-to-many relationship, we create a separate branch phone table. This design keeps the data organized and avoid repeating fields inside the branch table. For the next slide, we will talk about the bill calculation. For the bill calculation, we pre-calculate the tax service charge, and total amount based on the restaurant business rule. Tax is 30% and service charge is 10%. OBO records also follow a consistent data and a date and time format, which help maintain clean and reliable report. For next slide, we talk about operation summary. In RDML operations, we insert data for all main entities like branch, employee, customer, reservation, order, bill, and payment. Contact information was stored separately in phone and email table to support multiple entry per person or branch. We also insert sample transaction to show the full workflow from reservation to payment.
Queries. Here we have the basic select query. Here I'm demonstrating a basic select query. The goal is simply to retrieve customer information from our customer table. This validates our data has been inserted correctly and that our database is ready for more advanced operations. Then we have the left join. This slide shows a left join between customer and reservation. A left join is useful because it keeps all customers in the result. Even if they don't have matching reservation entries, this helps identify active versus inactive customers. Then we go to the group by and aggregate. Here I use group by along the count function to calculate how many reservations each customer has made. This type of summary is important for understanding the customer engagement and usage patterns. For the business queries, we have the first one, which customer made the most reservation. This business query looks at the same aggregated reservation data, but now the purpose is business focused. Knowing which customers are most active helps the restaurant design loyalty rewards or targeted marketing. Secondly, we have which employees handled the most orders. I measured employee performance by counting the number of orders handled by each staff member. This helps management understand workload distribution and identify high-performing employees. For the third business query, we have which menu items generate the highest revenue. For this query, I calculated which menu items generate the most revenue. This insight is essential for optimizing the menu, adjusting pricing strategies, and focusing promotion on high margin items. Then we go to the fourth, which restaurant branch handles the most reservation. We show here the reservation volume by branch. Identifying which branch is the busiest helps management allocate resources, staff, and inventory more efficiently. For the final business query, we have which bills generated the highest tips. In this final business query, I analyzed tips to see which customers gave the highest amounts. High tips often correlate with excellent service or special occasions, and this data helps better understand customer satisfaction. In summary, for part 4, I demonstrated how SQL queries can provide meaningful operational and business insights. From simple data retrieval to business-driven analytics, these queries support better decision-making and improve overall restaurant performance.
We use a transaction to safety update menu data. In this example, we increase the food cost for steak and adapt a seasonal dessert, the strawberry pie. Assume the seasonal dessert is accidentally deleted and rollback stores restore the item immediately. For the next slide, by wrapping this action inside a transaction and commission, then only when all steps succeed, we ensure data accuracy and provide partial update. We also indicate how rollback protect data. This shows how transaction can prevent data lost. For next slide, this example shows a transaction where is a customer add an extra tips. We update the bill and insert the payment together in one transaction. This ensures the bill amount and the payment record always stay consistent. For the final slide, to conclusion, our system is normalization, consistent, and support the full restaurant workflow from reservation to payment. Our our relation sigma maintains strong data integrity, and our core and transaction indicates how the system can support real operation and decision making. Thank you for your listening.